welcome back. So what we're doing in this video is assembling the Speeduino VM-tronics. Hopefully you can see that right there. I'll kind of go through everything that the kit comes with. This is what I'm going to use is first test this on my Volvo B230 that I just built, and then I'm going to be going to powering a rotary with it, because they can do rotary timing up to 4 individual injector or coils. Like, it's pretty mint. For the price too, is crazy. I think total for everything that I bought was, with the Arduino and everything else, was like $180. It's like pretty dope. So I'm gonna unbox all this stuff, kind of lay everything out and show you what we're doing. Right, so I'm gonna start laying all this stuff down here. Hopefully you can see this. So what we have is the actual PCB board, which is this guy right here. Really nice. All of the resistors, capacitors, and like transistors, like MOSFETs, pretty much everything you need in order to get this thing to function properly. Everything's labeled, has all the diodes. You can see diode has the MOSFETs for your transistors, different sockets for different inputs. Got all of your these guys. Let's see, this is terminals. Yeah, so also more capacitors, resistors, so lots and lots of stuff. But really, not too bad. So what I'm gonna do is I'm gonna go through and do probably resistors first, then capacitors, because capacitors and resistors are, the direction doesn't matter when you solder them in. But the LEDs, the diodes, and what else is there? Do they have any other ones? I think it's just the LEDs and the diodes are directional. So you have like a longer, like here's an LED. So you'll have like one leg will be longer than the other. One's the anode, one's the cathode. I don't remember off the top of my head which one's which, but they are directional. Same with like, what is this? These diodes. Yeah, here's a diode rectifier. The diode rectifier, yeah, these are also directional. So you can see kind of this guy. So this is everything that comes in the Speeduino 0.43 kit. And then if you're going to be doing something with a like a Haltech, not a Haltech, like a like off of a distributor for your timing, where it's like a mag pickup, you're going to need a dual signal conditioner, so it conditions the signal from a sine wave to a pulse. And for the older style injectors, this is the harness plug for the board. And then for the older style injectors, you need they're low ohm injectors, so you need to have resistors to be able to fire the low ohm injectors like old vehicles have. And then the other thing that you need is a Arduino Mega, which is how you went with the ePalZone XP, and looks like this. And this is what we'll actually be using to control what was it, the like the software end of things, to be able to the Tuner Studio. So this goes on last, so you don't need to put this in yet. But let me get the camera closer and I'll start kind of putting things out, and then we'll start putting it together. Okay, so they suggest in comments to install resistors first, then diodes, which include the LEDs, then the capacitors, and then you want to do your jumpers, then the Arduino pins, and then your IDC40 connector, IC sockets, all screw terminals, then all the MOSFETs, then the power regulator, then the map sensor if you're using it. So I'm going to organize everything into resistors, capacitors, diodes, and then MOSFETs. Okay, so we have our resistors, which is, so we have our board, we have resistors, 100K, 2K, 10K, 3.9K, 120 ohms, 1K, 2.49K, and 470 ohms. So a total of 1, 2, 3, 4, 5, 6, 7, 8 total different resistors. And there's quite a few of them. So in the instructions, it'll show you which go where. So what I'm going to do is start putting the resistors in. And on the board, it's labeled what ones go where. So you'll have like R. So what I'll do is I'll go through and do a group, right? So like this pack right here, it says 2K ohm, and it's R9, R10, R11, R12, R23, R24, R25, R26, and R52. So each one of those goes into one of the sockets, labeled, and everything's labeled. So we just go one at a time. And you want to be very methodical and very organized with this, because it can get overwhelming if you've never done like stuff like this before. So just be gentle with stuff. Make sure you have a nice pair of like flush cut clippers. You got all your soldering equipment, tinning, and all that good stuff. So now I'm going to start laying each one of these into the corresponding board, and we'll get to soldering them. I'm going to get all these resistors in, and I'll kind of do a close-up, show you how what I did, and kind of keep updating as I go. Okay, so here's my first update. I have all of the resistors soldered in. Every single one. There's 63 in total. They're all labeled. Different ohms, different ohm ratings, and they're all labeled nice, which is pretty cool. You can kind of see how that's labeled like that, and all of the resistors are labeled. So now I'm going to go through. I'm going to do all the diodes and LEDs and things, and then I'll give you an update after that. Alright, so you can see how I have my LEDs and my capacitors installed now. Now there's two things that are different on the 0.4.3.D board, which is the newer one. The LEDs, in the instructions, the short leg goes into the square hole, and instead of the short leg going into the round hole. The short leg is the negative side. So the negative side of the LEDs go into the square hole on these. And then the new capacitors have this little negative symbol on it. The short leg is the negative. And so that goes into the white of this capacitor. See that little positive symbol right there? So the long leg goes into the positive side. And that's just the differences in the newer board versus the other ones. The video that they have up is for the .4.3.C board. So that's just a couple of differences. Other than that, like, this is going together like a breeze. Super easy. Everything's labeled really well. It's awesome. So I'll get finishing up, and then I'll update more. Generals gathered in their masses, just like witches at black masses. Evil minds that plot destruction, sorcerer of deconstruction. In the fields the bodies burning, as the war machine keeps turning. Then hatred to mankind, poisoning their brainwashed minds. Oh Lord, yeah. Oh. Well, okay. Well, I don't really know what to talk about, so I'm just gonna ramble, I guess. So the Speeduino is put together. I've been testing it a little bit. I have all of the electronics that I'm going to be using for timing and like all the stuff to control it. So what I have is this guy right here, which is I guess you call it a crank position sensor. It's just a variable reluctance sensor. There's like a little coil of wire and a magnet here, and that will be mounted to somewhere on the near the crankshaft. And this is a 36-to-1 trigger wheel off of, I think, like a Lincoln or something. I don't know, it was like 15 bucks on Amazon. And this will be our trigger system, because on Volvos they have like a weird trigger system where it's like the back of the flywheel. On the autos it's like a 56-2-2 or something strange, I don't know. But I'm not using that, I'm going manual, and the manual flywheel that I have doesn't have that, so I'm going to be doing my own electrical system, which is nice because I don't have to use any of the stock ECU stuff, and this is very cheap to do. Doing this actually is cheaper than buying an ECU, like a used ECU for the for a Volvo. So I'm doing that. That'll be for timing. So my ignition events, basically, what you'll do in the software is you'll put in 36. So there's technically only 35 teeth on here, but it's 36 minus 1, so it's missing the other 36th. That'll log as an interrupt on your ECU, and that will basically trigger when the ECU, like that's basically how the ECU knows where your crank position is, and then it can fire your spark plugs to whatever you set it to, advanced timing, retarded timing, like whatever, your curve in the software. The other thing that I'm using is the stock coolant temp sensor. It's a Bosch sensor. So this is what I had with the car. I'm not going to buy another one. But the Bosch, it's just you select Bosch and it's already set up and it works perfectly. It's like within a degree of accuracy for what my house temp was, and I was testing it with like a hairdryer and stuff. The other thing is a throttle position sensor. This is from an E36, because the Volvo throttle position sensor for the 240s, at least, I don't know about the 740s or any other cars, is a it's like a switch. It's like, so it has wide open throttle, idle, and what was the other one? Cruise. So there isn't like, it's not like a potentiometer where you get like a voltage reading. So the Speeduino can't read those, and I'm not going to try and like jerry rig it. So I just got this. It fits right on. Let's see if I can find the throttle thing quick. In here somewhere. Here we are. So you can actually see that on this guy, there's like a little D-shaped bar where the throttle thing sits on, and it fits perfectly. Very, very snug fit. And so what I'm going to do is I'm going to 3D print a mount, so this can just basically like, this can bolt in the correct position for 0, which I believe is like, I think this is 0 right here. I'll have to double check. But so that'll mount to this bracket and then basically hold it, and then, excuse me. Oh, actually, you know what? This is probably 0 then. Yeah, there we go. So that is the 0 position, which is like right there, kind of in that position. I'm going to make a little mount. So this will basically bolt to here, and this will bolt to the 3D printed mount. And then this will be your throttle position sensor, which is pretty nice. And these are very easy to set up because it's just a potentiometer with a voltage drop of 0 to 5 volts. The other thing is the idle, which Volvo has a 3-wire pulse width modulated idle control valve. It's not like the IAC. That's like a I forgot what the other type are, but whatever. Like Ford ones are common. This is just a 3-wire PWM, very easy to take control of. So we're going to use this original one with the ECU, and then for the ignition system, we have just a very standard. I mean, like I think the Volvos even come with these, are Chrysler ignition modules. So you have basically, I forget which one. I think well, whatever. I'll put a thing up so I'm not, spreading misinformation or whatever. But basically, you have your net power and ground for the module, and you have your ECU trigger and your ECU ground, so that it'll ground the ECU will ground out this. This will send the fire to your coil. Coil will fire through the distributor, fire spark plugs. So very simple, very easy to hook up. And then obviously this guy, which is like the main thing, is my Arduino. Very nice. Everything is all soldered in. The one thing I did have issue with was the integrated map sensor thing right here. It was giving me issues where like it's not working in here. It's like shorting inside the board or something. I probably fucked something up. So I'm just gonna wire it to here. I already tested it. It already works. And I'm gonna be using a GM 2.5 bar map sensor because that gives me like a good range. Because I'm probably never gonna go above like 20 psi or something if I do with this car. So that is good. That's all set up for this. That's pretty much you know, that's about everything that I've got so far on it. What else is there to talk about? Oh, I got this guy, Dave Hobbs or something in Connecticut. He gave me some cool stuff when I got my my M46 transmission from him. Got some sick Volvo mud flaps. Look at those things. So apparently 740 M46s don't swap into 240s. They are completely wrong. So you need to make sure when you get if you go to do a manual swap, either go with like a T5, which is probably going to cost you about $1,000 in total or so for all the like bell housing adapters and all that stuff off of like a Mustang, or make sure it's a 240 M46 because the 740s are different. They have different tail houses. They have different lengths, different mounting positions for the for like all the brackets and stuff to mount it up. They're all different. Uses a different pilot wheel, all that stuff. So make sure you get a 241. Yeah. Hey, welcome back. So I have the Arduino done. I'm gonna go through some of the sensors that I am putting on, like what I did to get them to work. Some of the things I'm taking off. This thing is pretty sick. Like, it's really, really cool. So I'll get like a close in. I'll go through all the sensors, kind of tell you what I'm doing for this build and what you can do for your style of build, whether that be, you know, rotary, V8, 4-cylinder, 3, it doesn't matter. This thing goes up to 8 cylinders, so, or 10. No, it's V8, up to V8. I think there's expansion bays maybe for up to V12, but I'm not positive on that. But let me get you in close and I'll show you. So, get my microphone here. Okay, so what we have here is the Arduino itself. You can see everything's all soldered in. These are the wires that I'm going to be using. It's 20 in all for me. I'm not using some of the proto areas or some of the other stuff that I just don't need. There's like E85, which someday I would like to do flex fuel sensors and stuff, but I'm not worried about it for right now. This right here, this little box, like, I don't know if it'll, yeah, there you go. That is your dual conditioning circuit. This is for VR and Hall effect. You have to like jumper these pins. So I have this one, or not this one technically, but these 5 under here. See that little red thing? You direct where the voltage goes for your. Move this closer so you can hopefully not get weird noises. It redirects these jumpers redirect the voltage for your input signal. Basically, like if it's a VR, like a variable reluctance sensor or a Hall effect sensor. Variable reluctance is just 2-wire. Hall effect is like a 5-volt. I think it's 4 wires. Has like a reference, or maybe it's 3-wire. But I'm doing a VR because it's just easier. I don't need the Hall effect sensor. If you're going to be doing a stepper motor IAC, which would go right here. There's like a little module that you solder into this, and that's for controlling a 4-wire stepper because you need PID, which is PID control, which is proportional, integral, and derivative, I think. But I'm using a 3-wire IAC, and I'll show you that as well. So this is like the entire board. See, it's pretty simple and pretty small, and really, honestly, like it really didn't take that much to get to wire. The only issue that I did run into was my map sensor on the board right here. You can see this very well, but there's a right here is where you would plug your map sensor. And I messed up the first time because I put it in backwards. It's because it's like mount flat side down, but on the version, excuse me, 4.3b or something, it's the other way around, and I didn't realize that when I was soldering it, which is my mistake. I should have read more carefully, but they should update instructions like separate them. Even though there's only a few changes, they should separate them just because it makes it a little bit harder to do it. But anyway, I mounted this in upside down, and then it's I don't know if it like I don't think it fried anything. It just wouldn't work, and I couldn't unsolder it to flip it. And I think that's what happens when I was unsoldering this to try and fix it. I shorted some stuff out, and it just won't. It wouldn't recognize. So the map sensor actually has, you have wiring in for a map sensor. You have a 0, you can use a ground and a 5-volt reference, and then you have your 5-volt map sensor input. So you can just wire it directly to these guys. You don't have to really worry about it, which is cool. All you need, 12-volt in, ground. I'm going to fuse this with this whole board probably only pulls 2 amps at absolute max, but I'll just throw the smallest fuse I have on anyway, and I'm probably going to put this on a relay also, and then use a diode on the relay, because the really you want the diode to protect the like potential backfeeds from things, like other relays shutting down, voltage spikes from your alternator or battery or whatever. All sorts of stuff can cause voltage flyback, and your diode is basically a check valve for electricity. It allows current to flow one way and not the other, so I'm just going to put that in between the relay switch for the board. So let me get everything laid out, and I'll show you all of the components that I'm using. Okay, so on the table you have here, you can mostly see it. Just a little bit this way. Okay, so we'll start from this guy right here. So this is your VR sensor right here, and it's a 2-wire. Basically what it does is it interacts with one of these guys, which this is a 36-to-1. You can see there's technically 36 of these teeth. It's 36 minus 1, so there's missing one, so technically there's 35, but there would be 36 of this one right here. And what this does is it spins and it generates an electromagnetic field in this coil, because this guy is just a coil with a magnet and 2 wires. And this will generate a 12, I think it can peak up to, depending on how fast this is going, it can peak up to like, I think 20 volts-ish, somewhere around there, 18 volts. But basically it creates a 0 to 12 volt sine wave as it passes these teeth. So it goes, and it breaks. And then as it breaks, 12 volts, hits 0, breaks, 12 volts, hits, breaks. And it does this the entire spin of the crank where this little magnet is, right? And I'm going to mount. The spacing I'm going to put between this is 2 thou, and I kind of test it back and forth with this like mounting thing. I made a bracket. This is just a test piece to make sure it fits, but this is what will mount on the side of the block where the power steering bracket went, where the AC bracket went, and this will hold my VR, because you want it to be very solid. But anyway, so basically, in order to use this with the Speeduino, you just need the conditioner with that little solder on board that I showed you, and you feed one of these volts to ECU ground, the other one to the VR1 plus wiring. If you want to do sequential, this will only control batch firing fuel injection. If you want sequential fuel injection, which is every cylinder gets its own fuel injection at the correct firing pulse, like, you know, at whatever degrees or whatever, with only a single VR, you get batch firing. So you'll fire either all 4 or 2 and 2, 4 and 4, like depending on your engine setup, because like V6s are different, rotaries, whatever. It'll batch fire, so it'll fire all of them or half of them, or whatever. If you want sequential fuel injection, you need a cam and a crank sensor. And why you need that, why you need that is because the ECU needs to know where in the combustion stroke every piston is. So every piston will have a 720 degree rotation, you know, up, down, whatever, or 360, but only one of those up, down will be a combustion stroke. You don't want to squirt fuel into it if there's no combustion happening. So it needs to know when the valves are closed or when the valves are opening for the intake charge to let fuel in. And that's why you need both. You need 2. So the ECU knows where exactly every piston is, if it's on the intake or the exhaust stroke. So this is super easy. I'm just going to mount this to the dampener on the back. I have one that I made that's coming. This is just a test piece. you'd have to like cut this out and like modify it. I don't want to do that. So I just modeled one in Fusion 360 and then sent it to Send Cut Send. Should be here Saturday. It's like $24. So like, you can't beat that. Just buying one of these is like between $35 and $75 depending on where you buy it from. But this will control when basically when your ignition events happen, when your fuel injectors fire, all that good stuff. So that's like kind of a really important. I don't want to say it's the most important, but it is very important for fuel injection, especially for tuning and stuff. So we'll move that aside. The next thing we will look at is this. This is just your standard. This is a 2-bar. You can get them in 1-bar, 2-bar, 3-bar. I think they go up to like 100 psi. 3-wire. This is, I think, a GM or like a Holley style map sensor, but any map sensor with a 3-wire will work with the Speeduino as far as I know. Basically, I don't remember which one is which, but you'll just have like a 5-volt power, a 5-volt signal, and a ground, and that all feeds into the Speeduino. So you basically have 3 wires that go into Speeduino, and what this does is it's manifold absolute pressure. So this monitors the pressure in your manifold, and why that's important is because the ECU can determine how much oxygen is in the intake, basically based on the pressure inside the manifold and like the ideal gas law. So like it'll do it in conjunction to temperature and humidity, and well, maybe not humidity for this setup, but you can do humidity setups. But it'll make modifications based on coolant temp, based on air temp, like intake air temp and stuff. But this is basically what your VE table is used to tune with for the most part. You can do TPS based, but I just like map because it's extremely reliable and easy to do. It's like a cheat code for tuning. But some stuff this is not useful for. You can't use these in ITB setups because ITBs basically are always either at vacuum or full throttle, pretty much. There's a very minute area where like the throttle blades in the independent throttle bodies crack open a little bit, and you get like a change in pressure. But it's so minute and so fast that this can't really keep up with that. It's not ideal for tuning it. So you tune an alpha N, which is the degrees of your throttle input. So you can use these in conjunction with it to kind of help get the like sort of off throttle, on throttle, sort of idle stuff good. But for the most part, for an ITB setup, you would use TPS based. But this is great. Your volume, your VE table is RPM versus your map pressure. So like, excuse me. So this is 2-bar, which is 24 or 25.1 psi or something, or 25 psi. You can get 3-bar. Basically, 1-bar is atmospheric pressure. 2-bar is double atmosphere, so 28 point whatever. And 3 bars, 3 atmospheres of boost. And this can measure down to a vacuum of 0 absolute pressure. Super easy. So how this works, actually, let me explain that too. Is you have I don't remember which ones are these, but just bear with me. You have a 5-volt and a ground, right? So you have 5-volt and ground. You have a basically a potentiometer in here that's reactant to pressure changes, and it causes the resistance to change inside of here, and it drops the voltage. So you have a 0 to 5-volt signal that will vary depending on these are set from the factory, so depending on the scaling that it has. So like, we'll say 100 kPa, which is at atmosphere, like full, no boost, but full wide open throttle, just sitting at atmosphere. Basically, like the car is off. You'd be at 100 kPa, right? That would be at like 2.5 volts is what this would be reading, roughly, give or take. Kind of just, take that with a grain of salt. The scaling is its own, but. And then, 200 kPa, so like, 100 kPa of boost, or roughly 14 pounds of boost. This would read at 5 volts, like that. So that's kind of how you get, so it'll send 5 volts to the ECU here, and that's how the ECU will know what the manifold absolute pressure is at with this sensor. Super easy, super cheap. This was, I don't know, $17 on Amazon. I tested it, worked good, it's fine. Maybe you'd want to buy a brand name one. Like I'm not really that worried about it. It tested fine and it seems to work good, so I'm going to use that. All right, moving on to the next thing. Another important piece is your IAT. And this uses a thermistor, which is located, I don't know if it'll zoom in, or I don't know if it'll focus, but basically there's a little a thermal resistor in here that will change its resistance based on temperature. And so this goes in the intake, so like kind of like right at throttle body. I'm printing a thing right now that's gonna basically bolt in right here or wherever I decide to put it. And this measures the temperature of the air coming into the throttle body. And why that's important is because as air cools, you get, when people go out at night, they do boost runs at night, sometimes, get some crazy PSI numbers, or sometimes they'll blow their engine up. It's because there's more oxygen molecules in denser air. When it's cold, air gets denser. It means there's more oxygen molecules in a confined space. So this will make modifications to your VE table based on the intake air temp. And you can also set up safeties too, where it's like if it gets too warm, you can just inject more fuel to help cool the charge down, not to get more power or anything, but to cool it down so you don't detonate or ping. Super easy. It's just a 5-volt and a ground, and it's just 2-wire. These are super simple. And in the Speeduino software, you just pick which one. This is a GM, and it has like I would say like 90% of types of sensors you would be able to purchase on the market in the software. And this is pretty vital and very useful. I think this was a little pricey. I think it's like $26 or something, but still not bad. Whereas like if you were to buy a Holley one, it'd be like $100. Okay, on to the next. Let's do this guy. So unfortunately, I can't reuse this one, which sucks. This is a nice Bosch unit. It's off the Volvo, which is the same one that Porsche uses, like the old 944s, I think. But this is an idle air control. And inside of here, there's a little pintle that spins, open and close. There's different types that are like needle and stuff, but this is a 3-wire, and it spins a little vane, like a rotary vane inside there that lets air in or out. And how that works is there's a 12-volt signal here, so you put this to a 12-volt like ignition source or whatever, I don't know, switch power, whatever. Just find a 12-volt that's on while it's running. And then you have a ground side, a ground trigger, and a ground trigger. And on Speeduino, it's nice because it works. You don't need a resistor on one end to help facilitate closing the coil easier. Like it'll get like preferential and it won't work. But for the Speeduino, you don't need that. It's all encased in the unit, which is really nice. And you don't need the why does it out of focus? Come on, focus, man. There we go. You don't need the stepper motor control, the 3-wire or a 2-wire. So you put 12 volts here, you get a ground signal on each side, and it's basically like fighting to close or open it. And this bypasses air around so basically it'd go like, let's see if we can flip this over. Let's see, you see here? Okay, so this will bypass air from behind technically the way this is run would be behind the MAF sensor. I'm not running the MAF, I'm using the MAP, so I don't need the MAF sensor, but regardless, this will take air from before the throttle plate and redirect it through here into the manifold vacuum. So after the throttle plate, it'll just let air in and it'll tune your idle RPM based on the movement of this. So it'll kind of go up or down to open or close to allow more air or allow less air in. And these are just nice. You don't technically need to use these, but they're so easy to hook up and then make the tuning process so much easier. You might as well. I think I bought just like a knockoff one of these exact things with the same plug and everything for $17 or $15 on eBay. Like they're really cheap. You can get them. They all do the same thing. They're all 12 volt. Typically 12 volt center, ground on each side, but don't hold me to that. Some of them are different. All right, so that's your IAC valve. Oh, the other thing is you can get a 4-wire, which is a stepper motor, which basically controls a little pintle in and out, and it has like positions. So it's like up or down, and it's the PID controller. So you have like 0 to 256 bit resolution or whatever they are, and it'll have positions, and you can tune how fast they move, how fast it moves, how fast or slow it returns, how much it opens at X RPM, whatever. PID is you can control a lot more and a lot better. You get like a lot more accurate tuning, but they are a lot more finicky to learn to tune on, and a lot of people don't understand them. I'm still learning how to tune mine on the Holley, and it's a pain in the butt because you're all dealing with like proportional stuff. It's not like a 1-to-1. It's like stuff is like exponential or it's just like weird. These are easy, super easy to tune. They're easy to wire in, easy to hook up where you get vacuum to. Like usually it's just a hose, so you don't have to like worry about like custom plates or anything. Some you do, but typically I like these ones. Okay. Now on to I guess I'll show the throttle body now because right there. So what I'm using on this is a E36. This is a BMW E36 automatic. I think it was an automatic because I think the manual was not
resistor type, but whatever. I think it's an automatic. It's an E36 TPS. And the Volvo TPS, I think I'd said this in the previous video, was basically a 3-switch. It had cruise, idle, and wide open throttle. And that basically dictated, it was just 3 positions that the ECU could know where the throttle position's at. And you can't really tune that. This is a resistor, so it's the exact same kind of thing as the map sensor. You have a 5-volt ground and then the signal coming from it, and it's just a resistor in there that as it changes the resistance, and that changes the voltage to the signal, and that's how you know where the TPS is. TPS is great for, you know, like fuel enrichments, because if you stab the throttle really quick, you want to add fuel quickly so you don't bog, or you can do a bunch of stuff with TPS. And this is the easiest way that I figured to mount this, was just a 3D printed standoff plate with a little hole inside of it, so it's all like sealed, like, so you can run boost through this and it won't leak. So a little seal and stuff in here. It's like circular. I nut certed the thing with these guys. Basically, you just hook these up to a. Oh, it's really bright. You basically hook these up to your soldering iron. They melt into the plastic and they make nice little like mounting points. Super cheap, super easy. I think this TPS was like $30, and the plastic, I mean, like, you know, if you have a 3D printer or you have the ability to like buy a 3D print offline, this would be like nickels. So it makes it very easy to tune and to transition over to the new style of TPS. This is a knock sensor. I am not going to be using this. I don't think Speeduino has like a built-in knock, and I don't really care to use it that much. I'll just be conservative with it. So I'm not trying to build a race car. You know, I'm trying to just build like a little drift car I can beat around and have fun with. This just retards or advances timing. Well, it doesn't advance, but it'll bring timing back in if it hears a frequency of detonation, and you have to tune these to have the right, have the correct frequency to know when it detonates, basically pinging, and this will just pull timing until it stops and then bring it back slowly as it drive goes through cycles and doesn't ping. Last thing that I'll be using on this is a very standard 4-pin, I think it's a Chrysler or GM style igniter. You have a coil positive, I can't remember, I think B, well, you can look it up online. They have them all. They have them all out there. I don't memorize these things, but it's basically a coil positive, coil negative, ECU ground, and then ECU trigger. And what this does is I'm going to be running my ignition system through. Let me turn the ISO down a little bit. It's not bright. Right, there we go. I'm going to be running the distributor, and I'm going to be using this to send power through the coil. Basically, pretty standard stuff. Basically, you charge up your coil, which is your, you know, like any old car. You can do like smart coils and stuff, but you need your VR2 and all that crap. Well, I guess you don't if you're doing like wasted spark, but whatever. This is the easiest and the cheapest way to do this, like kind of on a budget. This is like $7 or something. Before I forget, you do need to mount this with thermal paste so it dissipates heat. But as I was saying, you hook this up to the power negatives of your coil. The coil charges. The ECU tells it when to break the connection on the coil. So that break will cause a voltage spike into the like 15,000 volts, and that is what sparks your spark plugs. And I'm going to be running a wasted spark, so it'll basically fire, I think, spark on 1 and 2, or 1 and 4, and 2 and 3, I believe, for Volvos. Anyway, but yeah, super easy to hook up. This just runs to your coil, and then from your coil to your distributor cap, and your distributor cap to your spark plugs, and then ground and ECU trigger. And it's like super easy. All this stuff is really easy. It's like a couple of wires and very simple, very simple electronics. So yeah, I think that's it for this video for now. I'm still waiting on this camera. There we go. So I'm still waiting on the send cut send 36:1. Oh yeah, I think I should probably talk about that also. But basically, I'm waiting on my 36:1 wheel that I have made for the Volvo. What this does is it lets the ECU know where the crank is in position for firing the spark plugs and the fuel injectors. I kind of touched on this before, but basically how you set it up in Speeduino is you do a 36-to-1, and with the VR sensor and the way that mine's set up, you do a falling edge, which means that it's as this edge comes off of the mag pickup is your falling edge. Sometimes there's leading edge, sometimes there is a leading edge and then falling edge. So like leading edge would be like as it's rotating, kind of see it, as it's rotating to the tooth, that's leading, and that's when it'll fire. Or trailing is when it's going past it, and it logs an interrupt in the ECU, and that is an event basically. And what it does is it knows exactly where everything will be after it syncs. So it's very easy. I've already tested it. Had no problem syncing. I hooked up to a drill and just spun it, and it sunk. So yeah, I think that is it. So hopefully soon we'll be firing it up. Like I said, I'm waiting for my crank from Send Cut Send, my timing wheel, and still waiting on my IAC from eBay. And then I can put everything together. I'll do a video of like mounting the wheel to the actual harmonic dampener, so you can kind of see how I'm going about doing that. And then we should be able to fire it. Like everything else is ready to go. The engine bay is good. Sitting over there, the engine's ready. Oh yeah. I don't know. Oh, I don't think I showed. Oh yeah, I have not shown this in video yet. I've shown some of the shorts, but yeah, there it is. You can kind of see from here. The color's white with some like orange metallic gold flaking, and then Kitsugi style like painted things in the engine bay. But I'll do a close-up video of that before I mount the engine and stuff in there. There's the little engine, and there, right there, that's gonna be my big old pin street port, big turbo 12A. I'm gonna start doing that soon. I'm gonna be porting it, doing all the fun stuff to it. I was waiting for my engine to blow up, but it never did. And it never did blow up, so I'm just gonna build this engine now because I'm kind of bored and I want to do something. So yeah, leave a comment, like, subscribe, whatever. Peace.